Good afternoon, guys. Welcome to our Numpy lessons. I hope you are all fine. I would like to start our program development IDE. Before starting our lesson, I would like to give some information about the IDE. I mean integrated development environment that I've been using for presenting Numpy lessons for you. This is a member of Anaconda's utilities which are available in the web. It's totally free and use version 3.3.6, and this utility just allows me to save sample programs and to perform them, to execute them, and to see the result. And during the execution of a program, interpretation of the program, I can see the variables that I defined inside the program, and I can see their types, and I can see their size and their content. So there is another pane here, history log pane, and sometimes again I can have a look here and can have an idea what I have done just before, and what's the process that I've been following. I can have an idea about that, and this gives an idea that what is the current file that I've been tangling with. This is the Project Explorer. Under the Project Explorer, there is a directory that I've created beforehand, and so far I have presented to you, lectured to you, two lessons, lesson 1 and lesson 2. This time we'll go on with lesson 3. In fact, just that's all that I want to say for the time being. And let's go on with our desktop. This is my desktop, in fact, and one by one we'll go Spyder demo programs. Let me change this with camera output. Yes. Okay. So far I have shown some examples of array manipulations, and this time I'll go on with that topic. As you remember, in order to use an array, Numpy array, you have to import Numpy module, and I use it with this shortage np as np. So I here define a variable a np.array, so it's gonna include 4 members, 1 2 3 4, and I here define another array. It contains 4 members actually. So my next variable will be assigned as the multiplication of these two, a and b. So after that I'd like to print the result. So when I run this code snippet, okay, by the way, there are some ways to run our code. I can prefer this symbol so as to run it, and just I can prefer this one, F5, or just by right clicking I can run this small snippet, and just after running the code snippet, I can see the result. So 10, 40, 90, and 160 can be seen in our console. This is my console, I forget to mention it. And just I said, these are the contents and types of the variables that I use during my snippet. And this is the first one. This is the second one. Okay, this is the third one, the result. Just you can check it. Why I am explaining this? If you use this Spyder, you will be familiar with this structure. Actually, this is a MATLAB format, MATLAB layout. I'm familiar with MATLAB utility, so I preferred this kind of layout. You guys, you prefer other pane structures here. Just it's up to you. It could be RStudio layout or original Spyder default layout. I prefer a MATLAB layout, as I said. Okay, let's go with another example. I here import a Numpy module, so I have to use it with my arrays. And here my a variable, so I have to assign as arrays inside in a nested structure. This is the first, this is the second, third, and fourth members elements, and my b variable, so it will be assigned as 1.0, 2.0, 3.0. As you see, this is a floating point. That means it's going to be manipulated as a floating point types. So just this is the paraphrasing first array, and I make it printed as print A, and an empty line, and this is second array, so this one will be printed here. And what I am expected to be printed out, first array plus second array, and after that A plus B will be printed. So just I can see here 1, 2, 3, 4 members. Just as you can guess, I run it. Okay, 1 dot, 2 dot, 3 dot, and this is printed, this is calculated and printed as float 46 type. So just resize this one. I also resize this one, and I see the contents of the final A plus B array. You can see here. Simply it's summed one by one. Okay, it's summed one by one, and here in the variable explorer pane you can see the existing values of our variables. And now we go on with our next example. Here I define an NP array with an range that I described beforehand. That means what's the meaning of this syntax? That means it's gonna be start with 0, and this is the upper limit, and the increment value will be 5. That means 5 times will be increased in each step, and this is assigned as a variable. I here, by using this method reshape, I reshape this a array so as to be 3, 4. So before modifying, I would like to print out original array and this one. Okay, and by leaving an empty line, I would like to print out modified array or reshaped array, and in order to see one by one, I use here an iteration. So this is the iteration variable here. As long as it is in np dot and the iteration, this is the keyword. So print x comma parentheses. Okay, just I would like to show you a result. Okay, just this is before modified, before the modification. Okay, the original array. Just I said from 0 up to 60, incrementing by 5. That means 0, 5, 10, 15, etc., etc. It's gonna be exist inside our array. And what is the final situation? Here, just a modified array. Yes, this is my modified array after executing this command. 0, 5, 10, 15 up to 55. Okay, not including 60. And just I'd like to show you this one. In each iteration, it accepts x, okay, x, and it expects the next figure, the next number. So next number will be supplied by means of this one. Okay. And according to its reshaped value, it will be printed out. Okay, let's go with another example. I here create a variable so as to include 0 up to 60, and it's gonna increase by 5 once again. So I reshape it by using this one. This is the original one, by the way, and this is the modified one. So I'd like to print out the original array, and I here would like to show you one manipulation for engineering purposes. Sometime we'd like to transpose, we'd like to make it transpose a matrix so as to find out a linear equation, multi-variable linear equation. So this T stands for that. That means transpose of A will be assigned to B variable. Transposing, we call it transposing. So after that, I'd like to print out this transposed A, and here modified array is there is an iteration, one more iteration here, and this time just you can see that so far it's very similar to our previous example. However, this structure will print out the results in a single line. That means in horizontal manner, not vertical manner, line by line. So just I'd like to make it printed. So okay, this is the original array. Okay, so as to include this and that. 0 starting from 0 up to 55, increasing 5. Okay, how about this reshaped? Okay, no, it's not printed. This is printed. Okay, transpose of A is printed. Just look, transposing means rows and columns are exchanged in space manner. So just 5 goes here like this, and 10 goes here like this, and 15 goes here, and this is the transpose of A. Okay, and by means of this iteration, okay, this is printed here. Okay, maybe you guys this may cause some confusion. In fact, this is just cosmetic. You don't have to, you're not obliged to follow these contents in this variable explorer pane. Just it is enough to see the result after you perform, after you run your snippet. I'm always curious about the result and the resultant types. That's why I have a look each time. It's not necessarily to see this pane. That's what I would want to explain for the time being. And by means of this structure, this is printed like this. Okay. And what about next? I here so far here I would like to show you C style order sorting and F style order. C style means for C family programming language structure standard, and F stands for Fortran style order. In C style it's sorted in row order. In Fortran F style it's sorted in column order. You can see when I run this structure here as similar in the previous example. This is the same. We're having transpose it, and this is the title for what I'm doing. And b dot copy, this is the keyword, order will be according to C. Okay, this is the important, and this is important. Okay, after that I printed it, and in a iteration, okay, I have to mention once again C, and this will be in horizontal manner. This is another one. This time will be in column order, the same iteration. Okay. This might like this, I think. Okay, and when I run this, okay, this is sorted in let me arrange this one. Okay, this is sorted in C style. Okay, and just have a look transposing this process. Okay, this is printed in row side, row manner, and this is printed after that in a single line. Okay, just printing in row order. Okay, and this is F style, printed in F order, column order. This one will be printed first, and after that here, here, and after that here. Okay, C order and F order, C style order or F style order. It's up to you. It can be preferred, any of them. Okay, let's go with our next example. Here I define an variable here A, and it's gonna be increased 5 by 5, and this is the original array, and this time I would like to get it printed not a vertical manner, in a horizontal manner. Just it's gonna give the same but in different structure, different format. all the others will be the same. Okay, this is the C style, this is the F style. Just you can see here, this is the original one. Okay, here it's not transposed. Just for the sake of simplicity, I ignored transposing that array. So just when you see here, you can see the C style difference and the F style. Just I said 0, 20, 40, 5, 25, 45, 10, 30, 50. Okay, how about our next example? I here define an array same as before, and I'd like to get it printed as original array. And here I define an iteration here, so it's gonna multiply it. That means double value of x will be printed out, and after having a line printed as modified array is, I'd like to print it. And there is an OP flags here, read write. This is necessary. Just later I will describe why is it chosen like this. But for the time being, just you can accept it as it is. And this is the format to assign it. And let me run this snippet. The first parts will be the same, okay, like this. And here I multiply by 2, so the original value will be multiplied, okay, like this. The original array is like this, okay, and original array like this, as you see. And after multiplication by 2, it becomes here. It becomes like this, and it's obtained, it's accomplished by using this structure. You establish an iteration structure, and you assign the value of x by 2, multiply by 2. And how about our next example? This time I'd like to print out in F order this time. So when I run this one, in an iteration manner, just okay, here I said at the end of the iteration it's printed in this format, as you can see, 0, 20, 40, okay, 5, 25, 45, 10, 30, 50, 10, 30, 50, 15, 35, 55. Because we preferred F order, that means Fortran order. It's been printed in a vertical column manner, and we preferred it to print out in a single line instead of line by line. And this is another example for using. And here I define another variable here, so as to be incremented by 5, and first array, and will be like this. Now just I'd like to run this one to find out how it will be seen. Okay. This is the original array that I created starting from 0, 5 up to 60, not including 60, and it's gonna have 3 rows, okay, and 4 columns, 3 rows, okay, 1, 2, 3, and 4 columns, 1, 2, 3, 4. This is the structure that I would like to reshape my array, and this is printed after this reshaping, okay. And second array, this time just I define another variable here, so as to be b, including 1, 2, 3, 4, and just here I'd like to show you a manipulation. Okay, this is the remaining modulo operator, and I would like to get it printed the remaining of this after this division. So I manage it by means of a iteration that accepts 2 arguments x and y. So this is the structure that I preferred in S format, and let's see how it will be. Okay, just this repetition will be performed each time during this iteration. Okay, 0 semicolon 1, 5 semicolon 2, 10 semicolon 3, 15 semicolon 4. Okay, 4 members, and 20 semicolon 1. Okay, and 25 semicolon 2, and 30 semicolon 3, 35 semicolon 5. As you see, the iteration is performed in horizontal manner in this example, and it's printed in a single line by means of this structure, and that's all, you guys. That's the end of this example, these lessons, and in my next lesson we'll go on with array manipulations. Probably I will show you matrix multiplication and matrix operations, and so far I think we're going very slowly, and actually I know the contents of this module, this lesson is very huge, and one by one, lesson by lesson, we'll go on and we'll improve our familiarity with Numpy. Maybe in the very first lessons you might have found it, have thought that it is not useful, it's not beneficial. However, I have to present all these kinds of structures that when you encounter in future, in next lessons, you must have been familiar with them. And that's all for the time being, you guys, and I wish you a very good day, and please evaluate the rest of the day outside, not like me. Bye bye.